So a couple of words about test-driven development. Unlike other things mentioned on this course, test-driven development is not exactly a test method, or it isn't related into any of the test levels or test process models. Test-driven development is actually a process model for software development. The ideas of extreme programming are something that are more or less applied in the test-driven development. The idea is that we are constantly making iterative development work and constantly being up to date on the design and on the test cases, and basically trying to keep the really feverish iteration idea of extreme programming and constant feedback alive. This, of course, is probably one of the reasons because the godfather of the test-driven development and the extreme programming is actually the same person, Kent Beck, who has been working on agile development, extreme programming and test-driven development for some years now. Basically, the extreme programming uses the constant feedback on different levels. The test-driven development, on the other hand, uses really simple model. If we want to add a feature or new thing into our product or service, we define a new test case. When this case works, the feature exists and we can be happy and design something else, meaning that we can design a new test case. Also, the idea is that we do constant refactoring and regression testing. Since we have all the test cases available, and we know all the features that the software need to have, and they have all their test cases, then we can do the regression testing whenever we need to, and when we add new features we can do refactoring to clean up the code from all the problems. So basically it sort of combines the ideas of fake it till you make it and keep it simple, stupid sayings on the design. So basically the idea of how test-driven development works is this. We design a new test case to either add new feature or improve the test case coverage of the existing set of test cases. If our software is still working after the new test case, we don't have to do anything else than design something else. Of course, this also means that if we add new test case, for example to measure performance, and we are already within the acceptable limits of performance, we can just add new test case to test out something else, like the conformance between two different modules or application of certain standard or how certain requirements are fulfilled with the software. Or the usual case, especially if we decide to add new feature, of course the system will not work, because the feature isn't there yet. So then we do the necessary development work, that is design, program and unit test the work until the system starts to work or the feature exists. Then we go to regression testing with the list of all test cases available. If something isn't working here, no matter if it's the new test case we just added or something from the earlier iterations, we keep working and doing the development and redesign work until everything works. When we have made every test case to work or every test case cleans properly, then we just refactor and clean the source code or the modules we have been doing the development in, and then go back to the first case here and develop new test case for a new feature or to improve the test case coverage for the existing system otherwise. So basically this loop keeps the system developing and we can add new features or improve the test case coverage, and what's most important is that we have always all the test cases needed to do validation and verification, for example that some feature exists or that some non-mechanical or non-functional requirement is fulfilled. However, there are some things which have to be said. Of course, this approach of using iteration, this here is a bit short-sighted. If we don't have strong idea of where we are going, we might go somewhere where we don't want to go, and we have to do extensive changes when it turns out that, okay, the outcome isn't exactly what we want. For example, we created a nice, crisp and fine game, but it doesn't work on the target platform because it uses too much memory, or that there's simply not enough room on the installation drive, or that our embedded software isn't actually going to be fast enough to work on the hardware we want to install it. So it means that we have to have sort of design patterns or extremely experienced developers who are able to come up with the solutions which are agile and able enough to fit on the target platform, which also means that we have to use people who already are familiar with the platform we are using and familiar with the tools we try to use the design-driven approach with. Of course, there's also other things. For example, the false sense of security, especially if there's no oversight on non-functional requirements, since all the test cases the test-driven development recommends are more or less functional requirements. We can test them, we can even automate them, but if our system requires non-functional requirements, something like the intuitivity of the user interface or readability of the user interface, it already throws a curveball on our design. How can we automate or do regression testing on something like easy to use or easy to learn or something like that? Additionally, there's also the problem that we might design something that in paper sounds really good, or we end up somewhere which on paper sounds really good but isn't simply working. Also, there's the pesticide paradox, meaning that we are using test cases and we are using test cases to lull us into false sense of security that everything works. So unless we take real good care in adding the new test cases, we will end up in a situation where the program or service probably has several bugs or features missing or problems, but we can't see them because we are constantly using the same set of test cases and test material and test interfaces and stubs and simulations to replace, for example, the real world, so that we see that all our cases say that the system works, but the set of test cases itself isn't complete or it's missing something crucial. Of course, this also means that the set of test cases and the amount of refactoring and regression testing becomes really laborious work, especially in the larger projects. This, of course, means that the test-driven development is a really nice way to approach your problem. If you are doing something that's relatively small, you more or less know where you want to be and what you want to do and what is sort of a correct or at least functional response or functional set of features which will be usable, which will make the end product usable in your target platform with the tools you have available. Also, it means that if the size isn't per lines of code isn't too much, then you probably are going to be able to use test-driven development and enjoy the benefit of always having test set for all the features and most of the requirements that you have already implemented for your software.